Today we will learn about specific heat capacity. Our question of the day is, why do you need oven mitts to take hot things out of the oven? Why is your wrist not burned by the air in the oven? So what is specific heat? Well, different substances have different properties related to heat. If equal quantities or amounts of heat are added to equal masses of two metals, for example, copper and magnesium, would the temperature of each rise the same number of degrees? Well, no, they wouldn't. You know their atomic structures are different, and so their physical properties are different as well. Specific heat is the property that tells how well substances hold on to the heat they gain. For example, the air in the oven loses its heat way faster than the hot pan or cookies do. The greater the specific heat of a substance, the more heat you need to raise the temperature. The better it can hold on to heat, and the slower it cools down. Water has a high specific heat, whereas metals have low specific heats. When boiling water, the pot will heat up faster than the water will. To calculate the heat added to a substance, we use the equation Q equals mc delta T, where Q is the heat in joules, m is the mass in grams, C is the specific heat capacity of the substance, and delta T is the change in temperature in degrees Celsius. As a reminder, always make sure your temperature is in Celsius and not Fahrenheit. You may notice that this formula is very similar to when we were calculating heat using heat of fusion and heat of vaporization. The only difference is instead of H, we have C delta T.
There is a second unit we can use to calculate heat energy called calories. A calorie is equal to 4.18 joules. The specific heat capacity of water is 1 per gram degree Celsius, or 4.18 joules per gram degree Celsius. Now, pause the video and try the show what you know questions. When you are done, you can resume playing the video. A 3-gram sample of aluminum was heated from 20 degrees Celsius to 66 degrees Celsius. What is the heat absorbed? Well, we know that Q, or the heat, equals M times the specific heat capacity C times the change in temperature, delta T. Q equals mc delta T. We know that the mass is 3 grams, so M is 3. We know that the specific heat capacity of aluminum is 0.902 joules per gram degree Celsius. And we know that the aluminum was heated from 20 to 66 degrees Celsius. So delta T is 66 minus 20 degrees Celsius. So we're going to multiply 3 times 0.902 times 46 and get a heat of 124.476 joules.
Now let's calculate the total amount of heat a pail of water would absorb sitting in the sun. 500 grams of water saw a temperature increase of 22 degrees Celsius. So once again, we're going to calculate Q for heat equals M mass times C specific heat capacity times delta T. So we know that Q is what we're looking for, the heat. M is the mass, or 500 grams. C is the specific heat capacity, which for water is 4.18 joules per gram degree Celsius. And the change in temperature is positive 22 because the temperature increased. Now Let's type all this in the calculator, and you will get a total of 44,880 joules, or 44.88 kilojoules. Now let's do number 3. The temperature of a 15-gram sample of aluminum fell from 35 degrees Celsius to 20 degrees Celsius. How much heat was lost? Well, once again, Q equals mc delta T, where the mass is 15 grams. The specific heat capacity of aluminum is 0.902 joules per gram degrees Celsius, and the change in temperature is from 35 to 20, which is 15 degrees Celsius. If you type all of this into the calculator, you will get 15 times 0.902 times 15, which is 202.95 joules. Now let's try number 4. A 28-gram copper watch absorbs 1,078 joules of energy. If the temperature began at 25 degrees Celsius, what was the final temperature of the water? Well, we know that the energy, Q, equals 1,078 joules. And the mass, M, is given as 28 grams. The specific heat capacity, C, for copper is 0.385 joules per gram degrees Celsius. And the delta T, or change in temperature, is what we are looking for. So we're going to solve this equation for delta T. So what you're going to do is you're going to say delta T equals 1,078 joules over 28 grams times 0.385 joule per gram degree Celsius. And when you type that into your calculator, you get 100 degrees Celsius. You will do the same thing for number 5 to get the formula. M equals 1063 over 0.450 times 150. So when you type that in the calculator, you get 15.74 grams.